Hmm. Okay. So last session, what we were discussing, 1 second. Okay. So we have seen the Python code for binary classification. We have also seen for multi-class classification. And then we have also seen for multi-label classification. Multi-label means when we have more than one label. That's when the multi-word comes. Now in this session, we will see multi-level. So multi-level classification. So we will see what is multi-level classification, what example we are going to take, and then we will build a basic Python code for that. So let's consider this table. If you can see one sample in this, let's say this sample. Now we have category of electronics. So every item that's mentioned here is belonging to category electronics. So if I want to build a hierarchy here, so this is how the hierarchy will be built. So electronics is the parent class. Then we have three classes under it. First one is mobile. Then we have laptop, and then we have tablet. Now under mobile, we again have two categories. First one is iOS, second is Android. In laptop, we have two types of categories again. First one is gaming laptop, and then second one is business. Now in tablet, like mobile, so in this example, we have just iOS, but yeah, it can also be divided into two categories, iOS and Android. Sorry. So this is, if you can see, any of these product will lie in any of these hierarchies, either this hierarchy or let's say this hierarchy or this hierarchy. So you can see that, I mean, electronics is the parent class of all classes. Then we have further subclasses, and then we have further more subclasses to these subclasses. So you can see there are multiple levels, right? So first level of class, then we have second level of classes, and then last third level of classes. So that's where when we have parent-child relationship, then that's the example of multi-level classification. So if I'll say apple of, we have a electronic item mobile of iOS, iOS operating system with 4 GB RAM and internal storage as 128. Its price is $999 and brand is Apple. So this is how the data will be passed. So we will build a model, we will train the model on this data, and then we will uh, basically give the new input to our model to predict what is the hierarchy of that new product that we are giving. For example, let's say we will basically give 16 GB RAM and Samsung is the brand, and then 512 GB is the storage. So our model should be able to predict whether the product that we are giving belongs to which hierarchy, whether it's a mobile, whether it's a laptop, whether it's a tablet, and then what further subcategory, whether it's a iOS, Android, or gaming, or uh, you know, business. So this is what we are going to achieve. So let me create. Okay, before that, okay, we will create a code map, but let me create a new Python module. Python file, multi-level, multi-level. Okay, let's write the code map here itself. So 0th step, necessary imports, correct? Step number 1 will be sample data set we will provide. Then step number, let me just paste it somewhere else. Okay, sample data set we will provide. Then step number 2 will be we will see what is encoding also. So because many times we require encoding in our features, right? So encode categorical features and labels. Then third step will be to define feature and multi level labels, right? Then we will do our train test split as usual. And at step number 5, we will define the model and train it. Then last step will be predict on new input. Okay, so this is what we are going to see. Let's, okay, necessary imports, it will be as and when required, it will automatically take care. Okay, so sample data set. So this is the data set that we want to use. So let's ask ChatGPT directly itself to convert this into Python dictionary. Convert this example into Python dict. We will take this because we, as a values, we will take it as a list instead of giving it like this. Let's copy this. We have pasted it, and next step, what we have to do, we have to convert that into data frame, right? So pd.data frame and pandas as pd we will import. So this is our data that we have, the sample data that we have taken as an example. Okay, let me see if I can decrease the fonts. Okay, font is little bit more, so let me make it 12. Perfect. Now what we will do, we will encode the categorical values and labels. So what are categorical values? So first is this has categorical values, and this has categorical values. So into 6 means for all the 6 entries, it is electronics only. Okay. Now this is categorical value and this is categorical value, right? So categorical value means something which is in a string and not number. So if you can see price, RAM, and storage GB, they are numerical number and we don't need to encode it or convert it into some other format because When we provide data to models, the data should be in numbers, right? So that's where whenever the data or any column which is there in the form of a string, we have to convert that into those categorical values we have to encode. So what will happen when we will encode this value? So let's say if I'm encoding this brand value. So what will happen? I will use some Python libraries to encode it. And what will happen? Once I will encode, so it will assign one number to each brand. So for example, Apple it will give 0. So wherever Apple is there, it will give 0 value to that. So this will also become 0. Samsung, it will give 1. Wherever Samsung is there, Dell it will give 2. Asus it will give 3. So this is what we will get after encoding this categorical value brand. Similarly, categories when we will encode, so we have only one category, so it will be assigned with the 0 value. Subcategories when we will encode, so mobile let's say it will give 0, so all the mobile 0 0. Laptop it will give 1, so 1 1 1. Tablet it will give 2. So like this the encoding happens. Because, and why we need to do encoding? Because our model basically works primarily on numbers because it do mathematical calculation behind the scene. So in order to convert the categorical values into numbers, we do encoding. Okay, cool. So let's encode these categorical values, categorical features and labels. So I will do label encoding. So we call it as label encoding. So LE underscore, first one is brand that I want to encode, right? So I will use label encoder. I'll create a label encoder ka instance for every column that I want to encode. Second is category. So LE underscore category. Again, one more instance I will create. Third is subcategory. So underscore LE underscore sub label encoder. LE underscore type also I want to create. So like this. So I have created 4 instances. Okay. Now next step is to basically create one more column which stores the. So yeah, so here we have this one, this one, this one, and this one, basically this one. We have these categorical values. So we will create 4 more columns, each for brand and category, subcategory, and type, which will represent the encoded values. So let's create those columns, 4 columns one by one. First one will be DF, and first one is brand I want to create. So brand, what type of column? It will be encoded column. So ENC, I will write something like this. And I will do LE brand. So I will use this particular instance that I have created to encode like this. Okay. And then I will use fit transform and uh, and I'll pass the column brand column here. So fit transform is basically it will encode the values. That's how we do. And for that, this particular class is imported from sklearn pre-processing label encoder. Okay, so that's how we will do. So it will create one more column with the encoded values of the brand categories, means this brand column. Second is DF category in category encoding when we will do category. I'll use LECAT and then fit transform category, then subcategory encoding subcategory, and then type encoding में like this. So you can see here I am using each of these instances here, right? Whatever I want to encode. Subcategory, for subcategory I'll use le.sub. For type encoding I'll use le.type. That's why I've created these 4 instances of label encoder to do label encoding for these 4 category or 4 columns having string values. So encoding we have done. Next step is basically we will define features and labels. So first X will be DF, and then we will give the encoded values, right? So first is brand encoding, category encoding. Uh, 1 second. Okay, so is if I'll open this table, so यहाँ पे brand encoding column will be created, and then category encoded, sorry, not table. In this table, these columns will be created, right? Encoding, category encoding. Third will be subcategory encoding, and fourth column will be type encoding. So these four more columns we have created by encoding these values, right? Now, when we want to decide the features, so what should be the feature? First will be the brand. Brand will be the feature, right? Second will be, what will be the second feature which will decide? Price. This will be the second feature. And RAM GB. I mean, the RAM in GB is the third feature, and storage in GB. So these are the four features that I will define. And I will be basically deciding the labels also, right? So labels will be, the first label will be category, then subcategory, and then type, right? Because we have seen, right, electronics के अंदर mobile is there, laptop is there, mobile के अंदर iOS, Android is there, right? So what was happening? So this is the category, and let's say we have done encoding here. So this is the parent class, and then its subclass or the child class was subcategory encoding, and then we have the subclass, sorry, one more subclass of subcategory as type, right? So that's the hierarchy we have seen. So we will define these three labels. So this is the example of multi-label also and multi-level also, right? Because we have more than one feature, so it becomes multi-label. And the feature, all these three labels belongs to some category or some parent-child relationship or are in a hierarchy. So that is why this is an example of multi-level also, right? So this is what we will define as feature and labels. So first feature will be the brand encoded value, correct? Second feature will be the price. Third is RAM in GB, RAM in GB. And then fourth is storage in GB. So these are my input for the model that I will create, storage GB, okay? Now next is I have to define multi-level. So this is 2D matrix. So y, instead of small y, I'll represent it with the bigger, uppercase Y. And I will define my labels, multi-level labels. First one is category encoded. Second is subcategory, and third is type encoded. So this is correct, right? So this is how we have defined it. And then trained test split is something which will be as usual, right? So X train, comma, X test, comma, Y train, comma, Y test equal to train test split. And here we will give X, comma, Y, and then, yeah, whatever we give as usual, right? Next step is to define the model and train it. So what model I will define? So let's define a decision tree, non-linear model, decision tree classifier. And for multi-label, I told you, right? So we have to define multi-output classifier also. So I will use multi classification is to multi output. That's what we have done in the multi-label example also that we have seen last time, right? And then what will I do? Multi CLF dot fit. So this is where I train my data, correct? These all are usual steps. Now, last step is to basically predict on the new input. So let's take an example. So what example we are going to take? Let's take an example of Samsung laptop 16 GB RAM and 512 GB storage. This is the example which we will take. So यहाँ पे this as an input, what it will take model brand well मतलब means it will take basically Samsung as the input. Second, it will take price. So what is the price? Let's Samsung laptop 50 storage of 1500 of $1500, let's say. Okay, so here input will be Samsung $1500 and what else? RAM. What is RAM? 16 GB and storage. What is the storage? 512 GB. Okay, so understand what I'm trying to say here. So when I'm giving this input to my model, so it will just read these as an input that there is some Samsung product whose cost is $1500, whose RAM is 16 GB and whose internal storage is 512 GB. Now, as a model, my job is to predict what type of hierarchy it lies, whether it's a electronic product and then mobile or and iOS type or Android type, whether it's a tablet, and if it is a tablet then it's a iOS tablet or Android tablet, or whether it's a laptop, and if it's a laptop then whether it's a business laptop or gaming laptop. So that's what my model will predict out of this particular from this particular input, and we are training our model on this data, right? So this is our aim. This is the aim for the model. So let's see what it will predict when we train the data. So new input, let me take new input as directly I'll use pd dot data frame, and inside data frame let me directly I'll give brand encoded value here, encoded value like this. One value I'm giving, so it will be list having one item. So le brand dot transform and what type of product, sorry, the name of the brand, what is the name? It is Samsung. Okay, you see here, so this is a list having one item only, right? Because I am encoding one value, and brand encoded also, this is one item. So if in input, if I will be having more than one input, then I would be having more than one elements in this list like this. So here we have only one product, so that is why in square bracket we have only one value. That too we have encoded it right at the input. So Samsung, and this will be like this because we have only one element, so we will extract the element from the 0th index. Next is price. So price we can pass directly. So price we will be passing as $1500. Next is RAM GB. Next is storage GB. So RAM we have given 16, right? So let's change it to 16. And this will be 512. So this is our input. So this is what we are giving input. So that's what I have explained, right? So this is the input that we will give. Now my model's job is to predict the category, subcategory, and type of this particular product. So that is my aim basically. Now what will I do? I have provided my input in the encoded format. So my new prediction will be multi-CLF, the model that I have created, and then predict the new data. So my new prediction will be there. Now the prediction will be the encoded values, right? So I have to reverse encode or decode those values. So convert, what will be my next step? Convert prediction back to readable format. So how will I do that? So let's create one more variable, new pred, and let's say df equal to pd dot data frame, and I will pass on. So here what is happening? It is basically predicting, and it is giving category encoded value, subcategory encoded value, and type encoded value like this. Now my aim is to basically decode these values. So here I will take the column name as category itself, subcategory itself, and then type itself, because I'm decoding, reverse encoding basically, right? So first will be the category that I want to decode back, right? So category will be, so I will use le underscore cat. So for all coding, decoding for any particular columns, we will be using these instance variable that we have created before, right? So if we want to encode or decode category, so we will use lecat. If we want to encode or decode subcategory, we will use le underscore sub. And similarly for brand and type, we will use le underscore brand and le underscore type respectively. So I want to decode back category. So le underscore cat dot. So we have one method known as inverse transform. And inverse transform, here what we will do. So inverse transform, we will be again, what we will do, new pred. So 0 means this is for this 0th input, because we are providing just one input, and the encoded value at 0th index, like this we will provide. Then next is subcategory. So here we will use le sub dot inverse transform. Then 0th will be the index, and 1 will refer to the first encoded column. I mean the encoded column at first index. Then we have type. So we will write new pred 0, 2. Okay, like this. And finally we will print new prediction for this product is something like this, and then we will print new pred df. So let's run this program and see what our model is returning us when we are running this. Okay, see, it has printed the output. So it is telling that your product is belonging to electronics category. It is a laptop and it is a business laptop. So you can see here, we are basically seeing the example of multi-label also and example of multi-level also. Why multi-level is there? Because we have more than one labels. And why multi-level? Because all the labels are in parent-child relationship. Correct? So this is how multi-level classification problems are being solved when we train the model using classification algorithm. So we have given our model. First of all, we have trained our model on the data set, sample data set. Then we have given our model the sample input, where we have provided the brand name, price, and storage RAM, and GB of RAM, and then the storage capacity. And then it has provided us the multi-level output. It is telling us that the product that you are, giving belongs to electronics category, belongs to laptop subcategory, and belongs to business type. So this is the example of multi-level classification. Now, last thing that we will see in supervised learning is performance evaluation metrics. So we have seen, right, statistics we have seen during regression when we were discussing performance evaluation metrics. So here we will be seeing the performance evaluation metrics for classification problems. So some of the metrics I will just let you know. So there are two types of metrics. First is non-error based. So non-error based matrices are accuracy, precision, recall, and F1 score. And then we have error based metrics. So error based metrics are something known as error rate, then false positive rate, then we have false negative rate, and yeah, these are the ones. So uh, we will first see what are these, and then we will just see the range of these values to decide whether our model is good fit, bad fit, or not fit. Okay. So let's take an example, and we will wrap up our session, early today, because next topic that we want to start is clustering. So clustering we will see tomorrow, and we will wrap up clustering also tomorrow, and then our machine learning will be completed by tomorrow, and then we will start deep learning from next session. Okay, so I'll create one table. So first of all, customer IDs I am giving. So pay attention here, right? So this is a interesting concept. Actual class I am taking. And next is the predicted class. Outcome. This is outcome column. Okay. Okay. So customer ID can be anything. Okay. So let's take 10 examples. So first of all, we will be seeing the example of churned versus not churned. So churn means when the customer stops using the services or products. Not churn means the customer is continuing using the products, right? So our what you say, the focus class is churned. So all the output where we will see one, right, as the output, so that represent that the customer is churned. Wherever we see zero, we will understand that zero means the customer is not churned. Okay, so that is where we basically focus on class of interest. So our class of interest is churned here. So whenever churned is happening, it will be 1, and the opposite class is not churned, so it is 0. Let's say if let's flip the coin in another way. Yeah, right. So let's say if our uh, class of interest is not churned. So there I'll be representing the data not churned. If let's say 1 is written over there, so I will understand that as not churned. And if 0 would have been written there, then I would understand that it is a churned data. So as a first step, we have to decide what is our class of interest. So our class of interest is churned. That is why wherever 1 is written there, we will understand it as churned, and wherever 0 is written, we will understand it as non-churned. Okay. So let's take some example. So let's see, let's take that. Okay, let me fill this table real quick. So let's say that actual class 4 column 1, 2, 3, 4 churn and not churn 1, 2, 3, 4, 5 not churned and last one churned. Sorry, I have a bad throat today. So pardon me for the strange sounds that I'm making in between. Okay, so these are the 10 data that I have taken. Okay. And let's say that it is like this and like this. I'll explain you what I'm doing here. Yeah. Not churned. Okay, this is not churned. Sorry, not churned. Okay. So let's understand what this table represents. So this table represents the actual value and predicted value, right? So actual class and predicted class. For example, when I'm giving the data to my model, I have the actual output also written there, which I basically trained my model with, right? So there, whenever I'll be giving the data, it has the label whether the customer is churned or not, and yes and no is written over there, right? So that's the actual output. And when I train my model and then ask to predict on the same data that I have given for training and test data set, then it basically predicts some value. So that value is represented by this column, and this column basically represent the actual value. For example, my actual class says that yeah, my customer is churned, and my predicted model is predicting as churn only. So this is the correct prediction that it has done. Let's see this prediction. So my actual output was churned, but my model is predicting as not churned, right? So this is the wrong prediction that my model is doing, right? So that's why I have created all 3 to 4 types of combination that's possible using these two columns. So just remember that this column represents actual value and this column represents predicted value from the model. Now let's talk about the outcome. So outcome basically is divided into 4 categories. First is true positive. Second is false negative. Then false positive, true negative. So what it means is that if we'll take the example, this particular example. So this is the example of true positive because 1 we represent positive, 0 we will represent negative. So my actual is 1, predicted the value is also 1. So this is an example of true positive. That means my model is predicting the correct output. So it is a true positive situation. Let's say false negative. So let's say my actual class is 1, but my model is predicting 0, which is negative, right? So my model is what it is doing? It is predicting false negative. So false negative to positive, this we are judging based on the output that my model is predicting. So based on this particular column. Next is false positive. So if you take this example, right? Here the actual output is 0, but it is predicting 1. So 1 is a positive, which is false positive, right? So this is the example of false positive. Then true negative is that wherever actual result is 0 and my model is also predicting 0. So this is true negative. So these are the 4 situations my model can predict. So let's write down these, these outcomes one by one. So first is true positive. So I'll represent TP. Second is also TP. Third is it is positive, but my prediction is 0, which is negative. So negative, yeah, this negative is what kind of negative? False negative. So this becomes FN, false negative. This is true positive. This is false positive because my output is positive. Predicted output is positive, which is false. So false positive. This is true negative. This is true negative. This is again false positive because my predicted output is positive, which is false. So false positive. This is true negative. And this is my output is false, which my output is false. My output is negative, which is false. So it will be false negative. Now let's calculate total number of TP and all these 4 categories. Total number, how many are there? So TP, if I will calculate, how many TPs are there? 1, 2, 3. So 3. 3 true positives are there. Next category, let's say false negative, we will calculate. False negative, how many false negative are there? 1. And 2. 2 false negatives are there. Next category is false positive. How many false positives are there? 1, 2. 2 false positives are there. And then true negative. True negative will be 1, 2, 3. 3 true negatives are there. And if we'll sum these up, it should be 10, right? So 3 plus 6, 7, 8, 9, 10. Yeah, perfect. So we have calculated TP, FN, FP, TN. Now, accuracy. So when we talk about accuracy, so we are discussing about metrics now. So first matrix is accuracy. So accuracy is calculated by TP, true positive, plus TN, true negative, divided by total. So how much it will be? True positive is 3 and TN is 3. So 3 plus 3, 6 divided by 10. Total 10 entries are there, right? So it will be coming as 0.6. So this is the accuracy. Accuracy. Next, we will calculate precision. What is precision? So precision is calculated as true positive divided by true positive plus false positive. Okay. So true positive is 3. 3 divided by true positive 3 plus false positive 2. So 3 plus 2, 5. So 3 divided by 5. Again, it will come as 0.6. Next is recall. So recall is basically calculated as true positive divided by true positive plus false negative. So this will again come as 3 divided by 5, again 0.6. Next is F1 score. F1 score. So F1 score is calculated as 2 multiplied by numerator. We will take precision into recall divided by precision plus recall. So when we will calculate this also, it will come 2 into 0.6 into 0.6 divided by 0.6 plus 0.6. Again, when you will calculate, it will come as 0.6 only. So these are these accuracy, precision, recall, F1 score are non-error based metrics. Now let's see what are error based matrices. So first is error rate. So let's see what is error rate. So error rate is equal to false positive plus false negative divided by total. So it will come as 2 plus 2 divided by 10. It will come as 0.4. Next is false positive rate. False positive rate. So false positive rate means the rate of false positive. So numerator में false positive will come for sure, and denominator में it will be true negative plus false positive. So again, if we'll calculate, it will be 2 divided by 3 plus 2, 5. So it will be 0.4 again. Next is false negative rate. False negative rate. It will be false negative divided by false negative plus true positive. False negative plus true positive. This will be again 2 divided by 2 plus 3 equal to 0.4. It will be 0.4. So whatever this column we have explained now, this particular column, this belongs to error based metrics. So this is how this matrices are being calculated. Now we have something known as confusion matrix also. So confusion matrix, what is confusion matrix? So I'll explain you quickly that also. So for confusion matrix, so this kind of matrix is basically being made where these rows will basically represent the actual class. So this represents the actual class, and this column represents the predicted class. Let's say we have n by n classification. Let's say we have three classes, 0, 1, and 2. Let's say we want to, predict the size of the t-shirt into small, medium, and large. So small ko we are representing with 0, medium ko 1, large ko from number 2. So this is classification problem with three classes, right? So here we have three classes. So 0, 1, and 2. Correct. Now when we'll make confusion matrix, so what will happen? So this is the predicted value. So three values will be there. It's a three class multi-classification, right? So we will create 3 by 3 matrix here. So if we have four classes, so we'll create 4 by 4 matrix. If we have two classes, we will create 2 by 2 matrix. So we are creating 3 by 3 matrix and 0, 1, 2. So these rows represent, these are the actual values. These are the actual value. These are the predicted values. So let's say in this confusion matrix, and there are libraries to create confusion matrix, Python libraries. Now, how do you read that? So I'm teaching you that. Okay. Let's say the values in this confusion matrix is something like this. And something like this. So if all the values are lying in diagonal, then it means your model is predicting correctly. Okay, what it represents is that if we'll see first row. So यहाँ पे if I will decode the first row, what it is meaning is that my actual class is 0. So 0 में small size, let's say small size is there, right? And out of the all data, so I have 10 data. Predicted classes with 0. How many predicted classes? 10. So out of 10, sorry, not 10 data. I'm not talking about the all data. I'm talking about from the whole data. I have 10 data, 10 actual data, which belongs to 0 class. And in my prediction also, all the 10 data that I have predicted is from 0th class. That means my prediction for 0th class or small size is 100% correct, right? This is 100% correct. Let's see the second row here. So second row for class 1, right? So what does second row represent here? So second row represent that my actual class is 1, which is representing medium size of the t-shirt. In my prediction, out of 10 data that is there for a medium class, 9 is predicted under first category or M category, and 1 is predicted under third category. Third category, or what is the size? L. L is the size, right? So if you can see, so out of 10 predictions, my model is able to predict 9 correct predictions for M, or for the category 1, right? It has only predicted one incorrect category, which is, what is that incorrect category? It is predicting third. Not third, sorry, this should be 2. Sorry, my bad. So third category means the number 2. Similarly, for this row, if you will see, so my actual category is 2, and my model is predicting all 10 out of 10 under 2 categories. So that's why we say, if your maximum number, or if the confusion matrix is representing identity matrix, not identity, all the values are basically lying in diagonal, then it means your model is predicting correctly. So this is the concept of confusion matrix. I hope confusion matrix will not give confusion to you guys. This is something which you have to revise. You have to see this lecture again and again in order to understand it correctly, because these are, not easy concepts, I would say, but yeah, these concepts are something which you will eventually learn over time, right? So you have to practice, practice, and practice. So this is about these accuracy, error rate, confusion metrics, and all performance evaluation metrics that we have seen. Now let's discuss about the range, basically the range, percentage range, right? So if I talk about, so if we want to calculate the percentage, how you will calculate? You will just multiply whatever these numbers are there with 100 into 100, right? Okay. Now, when I talk about the error-based matrix, so when I'm talking about these matrices, so these are error-based matrices. So what will be the range for the good value, bad value, poor value? So for this, and I'm talking about percentages, right? So between 5 to 15. So 5 and 15, I'm taking the range. So these are error matrices. So error matrices means lower the better, right? And higher is poor. So if my range is less than 5, it is a excellent fit. If my range is between 5 and 15, it is a good fit. But if my range is more than 15, it is not a good fit. It's a poor fit. So this range less than 15, I'm talking in percentages. It's a acceptable range, and greater than 15, it's a poor range. Okay. So this is about error based matrices. Now let's talk about non-error based matrices. So when I'm talking about non-error based matrices, let's take two ranges. Let's take 70 and 90. So non-error based matrices are there. So for non-error based matrices, more the better, right? More the better. So when we divide this, So greater than 90 is a excellent range. Between 70 and 90 is a good range. And less than 70 is something which is a poor range. Okay. So that means anything greater than 70 is acceptable range. And anything less than 70 is a poor range. Okay. So this is how you define the ranges. So we have seen the complete ML, workflow pipeline for regression problem. Now your, assignment will be to create full ML pipeline for classification problem. And once you'll, solve those classification, you can take simple classification problem, either multi-class classification or binary classification problem. Calculate these matrices, calculate the acceptable and poor range, and then you write the logic to decide whether your model is a good fit, excellent fit, or poor fit. So take it as an assignment based on today's lecture. Cool. Any doubts? I know we don't have much attendance today, but I have recorded this session and I'll share it in our group so that other people will also understand what are classification based performance evaluation matrices. But any doubt so far what we have discussed? You need to revise these concepts again and again to get a good hold of all the concepts that we have discussed. Okay, cool. So yeah, so I think for today we are done with today's lecture. Tomorrow what we will do, we will discuss clustering, and then we will write the basic Python code for clustering and recommendation problem. Cool. If you don't have anything to add or any doubt.
No,
No doubt.
no, no.
Okay, then. Thank you, guys. Thank you for dialing in. Have a nice weekend ahead. Thank you.
Thank you. Bye bye.